Okay, so this video tutorial is going to involve kinematics. So there's four equations that you need to know, and they can be used for varying situations. So situations where you know time and acceleration and something like that, but you don't know something else. So I'm not going to run through all four of the equations and write them down for you. We're going to jump right into an example, and we're going to decide which equation we're going to use. So let's say that I've got a car and it is driving east, and it is going 30 meters per second. And its acceleration is -4 meters per second squared. First, what's happening to this car? Well, the sign of velocity is positive and my acceleration is negative, so this car is slowing down because the sign of velocity and acceleration are opposite. So this is my V initial, and let's say I've got a deer that is 50 meters away. Ooh. And I want to know, first, is the car going to hit the deer? And second, if it's not, how long is it going to take the car to stop? In other words, its time. So for the car to stop, well, that means its V final is going to be 0. So to figure out the distance that it takes the car to stop, in other words, to first see, is the car going to hit the deer? Well, I need to figure out, okay, well, what is my delta x for this car? Well, I could use, if I don't know time, I use the equation that does not involve time. V final squared equals V initial squared plus 2a times delta x. Now, I'm using x because I'm doing east-west. If I were going up and down, I would swap that out for delta y. So my V final squared is 0. My V initial squared is 30. So 30 squared is going to give us 900. So I've got 900 plus 2 times my negative acceleration, which is -4, times my delta x. And I'm looking for delta x. So I'm going to subtract 900 from both sides. And that gives me -8 times delta x. I went ahead and just distributed that. So dividing that, divided by 8, I get a delta x of 112.5 meters. So not only do you hit little Rudolph over here, you plow through him. So my delta x is 112. It was supposed to be 50. So these brakes are not working for this speed. So let's say I want to know, okay, what speed would I have to be going in order to not hit the deer? Okay, what's the maximum speed I could have with these brakes in order to not hit the deer? Well, in that case, I know 30 meters per second isn't going to work. So now I'm looking for my initial speed. So I would go V final squared again equals V initial squared plus 2a delta x. Now I know that the reindeer is 50 meters away. My acceleration is still 2 times -4. And now I'm looking for V squared. And again, my V final, because I'm going to a stop, is 0. So now, what I can do, 0 equals V initial squared. Now I've got -8 times 50. Well, that's going to give me -400. Well, if I add that to the other side, I get 400 equals vi squared, square root both sides. I get an initial velocity of 20 meters per second. So that's the max speed I could be going with those brakes. So let's do another example. Let's say I've got a car that is going 45 meters per second, and let's say I've got another car going 20 meters per second, but is accelerating at, let's say, 3 meters per second squared. This car is not accelerating. In other words, it has constant velocity. If you have constant velocity, that means your acceleration is 0. Now, let's say we've got a finish line that is, let's go with 30 meters away. No, let's go 50 meters away. Okay? And this is car A because he's accelerating, and this is car B because he's boring and does not accelerate. So first thing I want to know is which car will get to the finish line first. Okay? Well, to do that, the top car, since I have no acceleration, you use distance equals velocity times time. Well, I know my distance, that's 50 meters. I know my velocity is 45. I could solve for time. So 50 divided by 45 gives me 1.111111 seconds. So 1.11 seconds. Now, this car, to figure out its time, again, I am looking for time. I know my v initial, I know my acceleration, and I know my distance. The only thing I don't know is v final and time. So if I'm looking for time, what I could use is my delta x is going to be 50. I could use the equation delta x equals v initial times time plus 1/2 at squared. Now, I know my delta x is 50. My v initial is 20. I'm looking for time, and my acceleration is 3. So plus 1/2 times 3 t squared. Well, if I subtract 50 from both sides, I get negative 50 plus 20t, and then plus 1.5 t squared. Now, in this situation, I have to use the quadratic formula. So, t equals negative b, which is going to be negative 20, plus or minus the square root, b squared, which is 20 squared, so that gives me 400, minus 4ac, a is 1.5, and c is negative 50, all over 2a, that line really got away from me, all over 2a, which is going to be 2 times 1.5. So, plugging in what's in the square root into my calculator, I get 400 minus 4 times 1.5 times negative 50 becomes the square root of 700. So this equals negative 20 plus or minus the square root of 700 all over 2a, which is 3. So if I go negative 20 minus the square root of 700, and then all of that divided by 3, I get negative 15.4. That is not what I want. I can't have negative seconds. So what I need to do is negative 20 plus the square root of 700, and then all of that divided by 3. That gives me a total time of 2.15 seconds. So as you can see, car B gets there much faster than car A, even though it's not accelerating, because it has such a higher initial velocity. Now, let's do one more example, and let's jump into free fall. Free fall is a type of problem where we now have an initial velocity. So let's say I am on a cliff that's 20 meters high, and I drop, I don't know, one of my physics students off the cliff. No, let's use a baseball. I drop a baseball off the cliff. Since it's dropped, it's implied that my initial velocity is going to be 0. Now, if I'm dropping this on Earth, that means that my acceleration due to gravity is pulling the ball down, so it is negative 9.8 meters per second squared. Now, let's say I want to know how much time the ball is in the air before it hits the ground. So I'm looking for time. Well, I don't know what my V final is. I don't know what speed that ball hits the ground. So I can't use your favorite equation, V at, because I don't know V final and I don't know time. That's one equation with two unknowns. That doesn't work. But this 20 meters, I do know that my initial velocity, or my initial position, is 20, and I know that my final position is 0, or the ground. So my delta y becomes negative 20. So I could use the equation delta y equals my v initial times time plus 1/2 a t squared. Now my delta y is negative 20. My v initial times time, my v initial was 0, goes away. I am left with 1/2 times negative 9.88 times t squared. So I can solve for t by, first I can distribute that 1/2, so I've got negative 20 equals negative 4.9 t squared. So divide both sides by negative 4.9, and you get an answer of 4.08 equals t squared. So take the square root of that, and you get t equals 2.02 seconds. So that is a little taste of free fall, along with some practice with your kinematic equations.